This screencast is for Elementary Ed 4300, Methods in Teaching Science. Science Matters, Chapters 13 and 14. Chapter 13, The Restless Earth. Concepts covered include plate tectonics, seismology, and magnetic poles of the Earth. Plate tectonics is known as a theory of the Earth's outer shell divided into several plates that glide over the mantle. The plates act like a hard and rigid shell compared to the Earth's mantle. This strong outer layer is called the lithosphere. This illustration shows you how the plates are divided. The Earth is made of layers, and if you can see here in this illustration, the lithosphere is just the outer shell, almost like the shell of an egg. With the lithosphere, the plates are either being pushed apart or are subverging or converging with each other. There are three different main types of plate boundaries. Divergent is where the plates are spreading apart. Convergent is where the plates are subducting or coming together. And transformative is where the plates are sliding laterally or against each other side by side. In the transformative plates is where we have the earthquakes most often take place. There are three different locations where subduction can take place. You have the ocean-to-ocean convergence, where two plates actually converge under the ocean. Then we have the ocean-to-continent convergence. This is where a plate converges at a continent. And then last of all, we have continent-to-continent convergence. This is where we actually have land plates subducting toward each other, and you'll have one of the plates converging, one of them subducting, and the other one forming mountain ranges. Seismology is the study of earthquakes and seismic waves that move through and around the Earth. A seismologist is a scientist who studies earthquakes and seismic waves. Like we mentioned before, earthquakes usually take place along fault lines or where two plates are rubbing against each other. This sudden release of energy causes waves that make the ground shake. Seismic waves are the waves of energy caused by the sudden breaking of rock within the earth or an explosion caused by any type of explosion. They are the energy that travels through the earth and is recorded in seismographs. So actually the waves are what is recorded by a seismograph. The magnetic poles of the earth are formed because of the core of the earth, the iron core, and the release of the magnetic energy as it travels around the earth. And just like a magnet, we have a north and a south pole, and this magnetic field actually helps the earth to maintain its atmosphere. And this illustration shows how it does that. Solar winds and flares that come from the sun are actually deflected from the Earth's atmosphere through these magnetic fields. Also, these magnetic fields cause what we call the aurora borealis up in the northern hemisphere around the pole. This is from the debris from the solar flares interacting with the magnetic fields. Some questions we'd like to discuss about Chapter 13 are as follows. How does the Earth constantly change? We'll discuss this in class. And why is plate tectonics important to science? I'd like you to think of at least a couple of ways that the discovery of plate tectonics has helped us to explain some of the happenings on Earth. Chapter 14, Earth Cycles. Concepts from this chapter include the rock cycle, the water cycle, and the atmospheric cycle of Earth. The rock cycle. This is a system of change that occurs in Earth matter. Igneous rock can change into sedimentary rock or into metamorphic rock. Sedimentary rock can change into metamorphic rock or into igneous rock, and metamorphic rock can change into igneous or sedimentary. These types of rocks are constantly changing, and as illustrated in this diagram, you can see how the Earth is constantly changing matter through its lithosphere and then pulled down into the mantle, where the rock is again melted and turned back into magma. The hydrological cycle, also known as the water cycle or the H2O cycle, describes the continuous movement of water on, above, and below the surface of the Earth. The mass of water on Earth remains fairly constant over time, but the partitioning of water into major reservoirs of ice, fresh water, saline water or oceanic water, and atmospheric water is variable depending on our climate. So this illustration shows the water cycle and the multiple ways it flows through different atmospheric and ground conditions. So we have underground water is, like it said in the textbook, we have quite a lot of the water on Earth is underground, especially our fresh water. And we've been tapping into this water through wells, and we're kind of draining these aquifers. And this is something that concerns a lot of people, especially living in the desert like we are here in St. George. Then we have the atmospheric cycle, and these are the different layers of the atmospheric cycle. Earth is the only planet in the solar system with an atmosphere that can sustain life. So this cycle is really important to us. Earth's atmosphere is divided into 5 main layers. The first layer, closest to the Earth, is called the troposphere. It is the layer that is about 4 to 12 miles thick and contains half of Earth's atmosphere. Air is warmer near the ground and gets colder higher up. Nearly all of the water vapor and dust in the atmosphere are in this layer, and that is why clouds are formed here. You can see that here in this illustration. And as we go away from the Earth, we come to what's called the stratosphere. It starts above the troposphere and ends about 31 miles above ground. The ozone is abundant here, and it heats the atmosphere while also absorbing harmful radiation from the sun. So the stratosphere is very important in keeping us from getting fried, especially for sunburns. Then we have the thermosphere, which extends about 56 miles from the ground. Temperatures can get up to 2,700 degrees Fahrenheit at this altitude without the ozone protection. So you can see how hot it could get here on Earth without the stratosphere and the troposphere. Then we have the thermosphere. Oh, we already covered that. Then we have the exosphere. This is the highest level, and it's extremely thin, and this is where the atmosphere merges into outer space. It is composed of very widely dispersed particles of hydrogen and helium. These are the questions we'll discuss at the discussion's questions for Chapter 14. First, how does the Earth operate in cycles? And what cycles are there? And then second, why would scientists view the whole Earth as an integrated system of living and non-living cycles? So be ready to discuss these questions, and we'll see you in class.